So next up, we welcome a true community leader and Ceph veteran, Matthias Münch from Red Hat. With over 30 years of experience, Matthias helps customers find the optimal data management strategy. His talk, a generic Ceph sizer for the community, addresses a problem every architect knows: the lack of a universal sizing tool. He's introducing a new community project designed to simplify hardware planning by optimizing workloads, layouts, and BOMs. Find out how you can collaboratively shape his tool, and yes, it was not a mistake, his and this, because he is looking for contributors. Please welcome a true local from Berlin, Matthias Münch.
So I'm audible, I think, yeah, I hear it. So thank you for coming. Thank you for attending the talk. Who did some sizing of clusters in the past? Okay. How long you spent for a single cluster to be finished with the sizing? More than 2 hours? Okay, yeah, that's easy. Okay. So who am I? Matthias Münch, as stated, they are working as Red Hat in pre-sales, basically. And just I cared about some of the designs for the customers. And what I did in the past was always just trying to figure out how to do the calculation, right? Nowadays, I use mainly a calculator because other things are more tricky, perhaps. Who knows other sizers out there by vendors? So at least CLYSO has one. Okay, others are not. So what is the intention of the thing? Well, just if you design your own cluster, if you get a design, or you have to create a design for somebody else, usually you have an idea what your workloads are, perhaps you have an idea, and for that reason you go to just either your shop or to a hardware partner, and you sit down together, hopefully, and then you dig together the BOM, so the bill of material. So it might fit the desire well initially. However, I bet that you would need other rounds just to finalize on something that the hardware vendor might not understand really what you were after, and you might not know about all the different all the different kinds of hardware combinations that may be supported in a certain chassis. So, and because of all the things, I started then for myself to create new spreadsheets, and I ended then copying over for 8 versions the same thing, trying to fix this. And this was then the outcome, so try this programmatically. The aim is, well, we want to create quickly the BOMs for cluster design. We want to just be able to understand what are the supported combinations in hardware, the desired workload. We have specific configurations perhaps for different use cases. Stretching, so main failure domain and distribution might be a thing. And then do this all quickly as an overview, understand the bits and pieces perhaps might not be that important because many we don't have the knowledge usually. So I created something, at least some bare-bone one. I'm not a programmer really. And what is the year? So things working mainly, so one of our guys just used it or tried it, and well, there are flaws in just even in this these code parts. So what are we able, or what is able to do? Multiple chassis configurations can be loaded just from a file that you prepared. Just a vendor or partner could compile those because he has the knowledge. You can prepare multiple workload configurations with different information therein. You can load those, obviously. You can change the things and apply changes, and then you get a list of the things as an overview. And when you just did a mistake on the go, you can just change this and reload the things and so on and so forth. What's in there currently, a number of replicas so can use. It's replication only currently. Then multiple failure domains. We might have different distributions. Flash or no flash, object size, file size, things, number of object versions that you want to keep, and have you all in your mind, and you can write it down basically. And then you get a comprehensive list of the multiple BOMs based on the chassis configurations, and you'll get the overview for the different data centers. And what is in there is the first config errors shown there. So this is basically, I load a chassis configuration prepared, and it's just loaded into the table. So the table is nasty, as you see. I'm not a programmer. I tried to do that. And you see many, many configurations options. Jesus, that's the right word. However, it's just here now we load the workload configurations, and we see those workloads. So different file data, RBD, whatever you want to see there, and NVMe frontending is there. So configure it, apply the chassis changes, and we see the BOMs just showing up. So for the 7 configurations. This is not progress, this is real time. Yeah, well, this is the resulting configuration for the most optimal one. You see there just even CPU and memory, what you have at a minimum base and based on your drive size. Oh, I forgot to apply a workload, so there was 0 capacity. Let's reapply this. There is something important. We want to use a Radius Gateway cache media, and there is a problem. Well, I forgot to, this is not the right one, I forgot to set that I want to use Redis cache devices on the different configurations. Now the errors are gone, and we have a new configuration here. So that's the first thing, so we can look up what the configurations are. So it changed, so different sizes now. And you see here different need for CPU and memory, although you had the same number of servers, basically. Now we want to change the workload, just a different one. We add something. Here we see there are workloads just added for file, so Ceph. And we want to apply these not in the selected 3 data centers initially, but we have a 4th data center where we want to run this workload only, just correcting this from the previous one. And then we see here we have just fronting for the HDDs configured. There was a 0 for 0 flash percentage. So, well, now we have there a different configuration again. And we see here now HDDs applied as well. So this was done, well, I didn't change something except these things that you saw. This is the speed you can create configurations and negotiate on something that, the next part please, that you want to create. This is, so basically, how it looks like right now, and we can go to the next one. The wish list. So the ideas. First of all, the things were just variable settings for all the resources. CPU memory might not be the same for everyone that wants to create a cluster configuration. Number of NICs, ratio devices. These are known things that are dimensions. but also just adding costs per chassis or hardware things. Then I have fixed 8 configurations, so apply as you need it, change it on the go. The number of instance types, for instance, for scale-up for Redis gateways, we want to have just high bandwidth. Let's go with 20 for this one. And then just erasure coding is not there yet. Performance indications could go therein so that somebody understands, well, with this configuration based on this hardware, with these resources, we have the estimation of that performance. Export to config, settings, BOMs, blah, blah, blah. This is the long wish list. And why is this talk? So first of all, you can go there. There are some flaws in the actual code. Still, just even I said, well, this is rigging. It would be nice if somebody could see the value of such a tool. And if there is spare time, I would love to have more hands on the project. So it's just a repo right now. And well, you can access it, you can check it, and whatever is needed is welcomed, please. Thank you.
Thank you, Matthias. One more thing.
Yeah, just partner. It's not here. Advertisement. So we have Ceph meetups, one in Berlin and one in Frankfurt. You will find then out there on the tables just a QR code. If you are interested in it, just look for it. Just, yeah. Hopefully we see each other. Okay, thanks. And questions, perhaps? None? Fine.
So it seems no question at the moment, so we can stay in time. Thank you, Matthias Münch.
Welcome.